All right, hello everyone, and welcome back to M155 Mathematical Modeling. In this lesson, we're going to talk about index numbers, the Consumer Price Index or CPI. So, normal values, real values, and how we can compare quantities across different periods of time. So, that's what this is going to be looking at today. So this is extremely important because numbers by themselves can sometimes be very misleading. Okay. If I tell you that someone earned $40,000 in one year and $60,000 many years later, you might immediately say that $60,000 is better, right? But that conclusion ignores a very major question, which is what could those dollars at that time actually buy? Okay. And so that's where things like index numbers and inflation adjustments become very important. Okay. So let's begin with the index and comparison terms. All right. So an index is a value comparing a quantity with a base period. All right. An index is a value that compares a quantity with some base period. A base year is the reference year assigned an index value. So it's basically a reference year that we're going to use for comparison. Typically, the base year is assigned as an index value of like 100, right? So if an index value is equal to 100, where is the base level period? If the index increases from 100, the quantity has increased relative to the base period, okay? And then if the index falls below 100, the quantity has decreased relative to the base period. A common formula for calculating index is index equals the current value divided by the base value times 100%. Or, excuse me, we could just simply say 100. Okay. All right. So index equals current value divided by the base value times 100. Okay. That's the idea. Just zoom in here one more time. Okay. Next, we have CPI. CPI measures the changes in consumer prices, right, over time. We also need to distinguish between something called nominal value and real value. A nominal value is stated in current dollars without adjusting for changes in purchasing power. Okay. So a value stated in current dollars without adjustment or the adjustment in purchasing power. Say, for example, the $60,000 in the 1960 is 60K logically equivalent to $60,000 in 2006. I mean 2026. Absolutely not. 60 grand in 1960 could buy you so much more than 60,000 in 2026. 2026 60,000 is significantly less than what it actually is on paper. Okay? So nominal equals current dollars and real or real value equals inflation minus the adjusted dollars. Okay. Very important that you understand that. Okay. A value stated in current dollars without the adjustment, that's the nominal value, what it is on paper, versus the real value, a value adjusted for the changes in their purchasing power. Again, $60,000 today is not logically equivalent to $60,000 um, back in 1960. Okay. That's the big idea. All right. Example number one, interpret an index change. So suppose an index change rises from 100 to 135. What does that mean? Remember, 100 represents the base period. Okay. So this is the base period, right? That's the base period. The amount of increase is 135 minus 100, which equals 35. Now we're going to compare that increase to the original base index. Okay. So that increase, which is the current value. So I'll write this over here. So the current value is 35. We're going to divide that by 100. Okay. That's going to give us 0.35. Now we have to convert this to a percentage. So we're going to multiply this by 100%, which is going to give us 35%. Okay, relative to the base period. So notice something important. An index of 135, right? An index rise from 100 to 135. An index of 135 does not mean that there was a 135% increase. It means that the current value is 135% of the base value, which corresponds to a 35% increase. Okay. So a 35% increase, not a 135% increase. And that's important. Okay. Example number 2. Suppose CPI rises from 292 to 301, and we want to calculate the percentage change. So our percentage change formula is the new value minus original value divided by the original value. That will be multiplied by 100%. Okay, so I'm just going to input numbers in there. So it'll be 301 minus 292 divided by 292 times 100%. So when we subtract 301 minus 392, we end up with 9. That'd be 9 over 292 times 100%. 9 divided by 292 is going to give me 0.030082, and we're going to multiply that by 100%. Okay. After multiplying that by 100%, we end up with, I'm just going to use an approximation here. We're going to end up with 3.08%, or you can just move the decimal place 2 units right here, right? Okay, so therefore, the CPI increase was approximately 3.8 or 3.08%. Okay, so that means that consumer prices represented by this particular index, or the index change from here to here, increased by 3.08% over that period of time. Right? All right, you can pause and try this one. And there's also one on your corresponding sheet as well. All right, now let's consider the salary 48,000 and 48,000 to 53,000. At first, it sounds great, right? It's like, oh, we got a $2,000 pay raise, or in this case, a $5,000 pay raise, right? So let's calculate first of all the nominal percent change, right? So I'm going to use the percent change formula. Percent change formula. And remember, that's the new value minus the original divided by the original. So that's 53,000 minus 48,000 divided by 48,000 times 100%. Okay. So when we subtract the numerator, we're going to end up with $5,000 change. Then we're going to divide that by 48,000. Then we're going to multiply that by 100%. When we divide these two, we end up with 0.08%. 10417, and we're going to multiply that by 100%. And again, you can either, when you're multiplying by 100, you can just move it two places. If you're multiplying by 10, move it one place. If you're multiplying by 1,000, move it three places. That's how it's just easier with the base 10. So that being said, what we're going to do here is multiply it, remove the decimal place 2 units. That's going to give us 10.42. And again, that's an approximation, so I won't have to use every term. I just rounded this up here. So I rounded this right here. Any number greater than 5, I can bring this up 1. Okay, so that's why I wrote this up to 2. So that would be 10.42%. But we're also told, though, that the CPI increased by 12%, right? So a salary rises from this much while the CPI rises 12%. Explain how to compare real purchasing power. Okay, so again, the salary increased by 10% while consumer prices increased 12%. So a quick comparison is essentially taking the 10.42% and subtracting the 12% from that, and we're going to get a negative 1.58 percentage points. Okay, this is very, very important math. Okay, and this type of math again can get you a really good job if you just know how to do it. It's very easy. But what we want to do is look at this number. So although the person's paycheck was larger, right? They're like, we're going to give you a $5,000 raise. That's $5,000. That looks great on paper, right? It looks great, but the purchasing power likely decreased. Okay, based on the CPI, the rise of 12%, your purchasing power actually went down. So this is not a huge break for you. Okay, so we can also make a more precise inflation adjustment. If the prices increase by 12%, then the inflation factor is actually, because 12% is actually the same as 1 plus 0.12, which is 1.12. Okay, because 12%, essentially the inflation factor, right? That's what this is. Okay, so if the CPI rise 12%, well, the inflation factor of 1.12 is going to be used to see what actually happened. So the real salary is 53,000. So what we would do is we would divide that by 1.12, which is this number here. So the real salary would end up being $47,321.43. Okay. So that's technically, even though they're telling you, okay, well, you know, we're going to give you on paper, it's going to be 53,000. Well, based on the inflation factor, when we calculate this inflation factor of 12%, because you have to add 1 to that percent, because it's not this isn't one whole number. Okay, so you have to add that 1 to their getting this. You divide that inflation factor, or the CPI rise, to what you make on paper, and then this is actually how much you really make. Okay, that's your real salary. Now compare that with the original, 47,000 versus 48,000. Okay, obviously this is less, right? So even though the nominal salary increased from this to this, the inflation adjustment value is actually slightly lower. And so that is exactly why we distinguish between things like nominal and real values. Okay. All right, let's look at example number 3. A movie earned $100 million several decades ago, and another movie earned $150 million now, today. Which movie performed better financially? Okay. Because, and again, because $1 today is not logically equivalent to $1 several decades ago, in purchasing power. You got to understand that. So the older movies, $100 million decades ago, represents considerably more purchasing power than let's say $100 million today. All right. So you got to understand that. So when we take into consideration of inflation, we have to say inflation minus the adjusted value would give us the old value, and then we would multiply that by the inflation adjustment factor. Okay. All right. So again, inflation minus adjustment equals the old value times the inflation adjustment factor. Okay. So without knowing the appropriate index values, we cannot calculate the exact adjustment. So therefore, 100 million now is essentially greater than 100 million nominally. But that doesn't automatically mean that the newer movie earned more in real terms. Whenever we're comparing money across substantial amounts of time, like decades ago, right? Um, we have to have more information. Okay, have have these amounts been adjusted for inflation would be my question. Okay, because we don't have that type of data, so we can't necessarily conclude this. Okay, so explaining why inflation adjustments matter. Inflation adjustments are the only way that we be able to determine whether or not this money is greater than this money today, juxtaposed to the nominal version back then. Okay. Example number 4. Suppose a government benefit increases by 2%. That might sound like an improvement, right? But suppose the relevant cost index increased by 5%. So we have to compare the two. So the benefit increase, I'm going to call it the BI, went up 2%. Okay. And then the cost index, the cost index rose, call that CI, went up 5%. Okay. I'm just getting the data from this. So a quick approximation of the change in real purchasing power is basically just subtracting the two. 2% minus 5% is going to give us a negative 3%, right? So the recipient has approximately 3% less purchasing power, right? That's essentially what that means. For a more precise calculation, we would have to compare the growth factors. So, for example, the benefit factor would be essentially, let's see, the growth factor. So, anytime you take 2%, you would have to adjust that and say 1 plus 0.02, right? And which equals 1.02. That would be the growth factor. And then the cost, um, that would be the growth factor of the BI. Okay. And then of the CI, we got 5%. So that would just essentially be 1 plus 0.05. Notice how I'm just taking the percent and adding 1, taking the percent and adding 1. That's essentially, so this will be 1.05. Okay. So then we would take the real factor change of those two and basically divide them. So we'd have, 1.02 divided by 1.05, which is approximately 0.9714. Okay. So if we divide these two, we get 0.1794. And then if we subtract 1 from that, So I'm going to come back up here, 0.9714, and we subtract 1 from that, we would end up with negative 0.0286, right? And then when we convert that to a percentage by moving the decimal, we would end up with negative 2.86%. Okay. So purchasing power actually decreased, right? So this is the actual purchasing power of a decrease, or the actual decrease in purchasing power. Okay. Okay. Of 2.864%. But the important point is that a benefit can increase in nominal dollars while still losing real purchasing power, right? Because you're going to see, oh, we got a benefit rise of 2% while, you know, the cost index rose 5%. Well, obviously, the cost of items going up 5% and then you getting a benefit raise of 2%, well, you're going to be in the deficit. You're going to have to manage your money a lot better, or work more hours, or get a second job. That's how that works, okay? Common mistake. One of the most common mistakes in quantitative reasoning is assuming that a large dollar amount automatically means a better financial position. Suppose one salary is, let's say you got one salary of $45,000, and years later that salary goes to 60,000, right? We know no one is going to debate and say, "Oh, well, 60,000 isn't greater than 45,000." You'd say, "Oh yeah, well, I'm going to take this." Well, of course you would. Everybody should take this. But in reality, are you making the money that, are you able to have this actual purchasing power on paper? That's the question. Okay. But that's because this is only a nominal comparison. Okay. Okay. So just be careful. This is only nominal. When you get to the point where you can negotiate your wages, and they're like, oh, well, we'll give you $50,000 for this position. We feel like this is like our base salary. And, if you got some leg room and you can negotiate, always negotiate. Don't just take what they can give on paper just because they feel like, they can just offer you something and you're a knucklehead and you can just accept it. Okay. This is a nominal comparison. We still need information about the changes in prices. So the correct answer to this question, or the correct question is, how much purchasing power does my salary have? Okay. How much purchasing power does my salary actually have? So when they offer you 60,000, you say, okay, well, you're like, let me run some numbers, look at the CPI, see how much that money actually is. And then you get back to them. You say, well, I actually only have this much purchasing power based on this salary. So can you actually give me like 70,000? Because 70,000 on paper is really like 60,000 purchasing power. And I'm just kind of give you an idea. Okay. So again, let's summarize this lesson. So an index compares a quantity with a base period, right? So the base period is typically an index of 100, right? So the index is typically 100, and that's typically the base value, okay? Or the base period, I should say. Base period, all right? The basic index formula is the current value divided by the base value times 100. Okay. CPI helps measure changes in consumer prices. And when comparing money across time, always distinguish between nominal value and unadjusted dollars. Okay. Nominal value and unadjusted dollars, because you can have a nominal value, but what's the current dollar actually on paper? Okay, or excuse me, not on paper. And then you have the real value. The real is equal to your purchasing power adjustment dollars, okay, or the inflation minus the adjusted dollars. And then finally, remember what we did in the previous lesson when it came to the percentage change formula. The percentage change formula is the new value minus the old value or the original value divided by the original value times 100%. Okay, because numbers are meaningful only when we understand what those numbers actually are being compared to. Okay, that concludes this lesson, and I'll see you in the next one.